right. So here we're talking about 4.2, which is defining the trigonometric functions. So to begin this, most of you are probably familiar with sine, cosine, and tangent. Or at least the SOHCAHTOA or some. My favorite is some old hippie called another hippie tripping on acid, which, let's see. Some old hippie caught another hippie tripping on acid, right? SOHCAHTOA, this is a mnemonic for a way to memorize these trig functions, or at least the three basic trig functions, which is sine. We're saying the sine of some angle is equal to the opposite over the hypotenuse. So opposite divided by hypotenuse. Then we got the cosine of some angle is equal to the adjacent over the hypotenuse. And then we have TOA, which says the tangent of some angle is equal to the opposite over the adjacent. Side of the triangle. So maybe you know about all this. I kind of assumed you did, but I probably shouldn't. So I'm gonna kind of talk about this. This has to do with angles and right triangles. So let me create some space here. So I'll just create a new slide. All right. So first, we'll talk about a right triangle. Right. We have a triangle. Right triangle. All right. And you have to have an angle. So I'll start with we'll go with red, and we'll say that this is our angle. All right. That symbol there, theta, is just for an unknown angle, right? So this is an angle, and this is called your angle of perspective. All right. The angle of perspective dictates what is considered to be your opposite side of your triangle and your adjacent side. The opposite side is directly across from the angle. This is the opposite side of the triangle. Then your adjacent is directly touching your angle of perspective and not the adjacent side of your triangle. And it's not the hypotenuse, which the hypotenuse is just like it's always been, is the longest side of any right triangle. All right, so one thing to understand with this is that when your angle of perspective changes, so does your opposite and adjacent side. So in this same triangle, if I say, instead of my angle of perspective being right here, if I say, oh, I want my angle of perspective to be this one right here. To be this angle, right? This is my new angle of perspective. It'll always be one of the two angles that's not a right triangle, or the right angle, I should say. So over here, now if I make this my new angle of perspective, now over here, this would be the opposite. Now this would be the adjacent, and the hypotenuse is always the same. So your angle of perspective dictates what your opposite sides and your adjacent sides are for your right triangle. All right, so SOHCAHTOA, right? Some old hippie caught another hippie tripping on acid. That's my favorite saying, just it sticks with me. So if I'm saying, depending on, well, in general, right, sine of some angle of perspective is equal to the opposite side over the hypotenuse. Cosine of some angle of perspective is equal to the adjacent side over the hypotenuse. And tangent of some angle of perspective is equal to the opposite side over the adjacent side, right? So that's kind of just what this is, right? That was just this. And they say X and Y, but if you think about it as opposite and adjacent, you're going to be fine. The XY stuff, we'll get there. All right. But there's these other three trig functions. These are called the reciprocals. All right. So I'm going to start something new with that. The reciprocals. Reciprocal trig functions. All right, so there's 6 trig functions, right? We have sine, cosine, and tangent. These are the main 3, the original. All right, original. All right, but then each of the original has what's considered to be a reciprocal. All right, and if you know math, the reciprocal is always just 1 over that. So like the reciprocal, all right, the reciprocal functions for sine is cosecant. All right, so sine of theta, cosecant of theta. What does that mean? That it's the reciprocal, that we can say cosecant is just 1 over the sine of theta, right? That's what a reciprocal is. So then for cosine, the reciprocal is secant, all right, of an angle. So the cosine of some angle of perspective, the reciprocal of that is the secant, which is just 1 over the cosine of that angle. All right. In my mind, I kind of keep these. I can keep this together because I think to myself, sine, cosine, tangent, right? Some old hippie called another hippie tripping on acid. I can remember those. And then I can always think the reciprocal always has, for sine and cosine, because that's where people are going to get confused. The reciprocal has, like, if one is a S, the reciprocal of that is a C. If it is a C, the original is a C, the reciprocal of that is a S, right? So that helps me. I don't know, maybe it helps you. And then for tangent, it's pretty easy to get the reciprocal of that because it's called cotangent, right? And there's cotangent and tangent are reciprocals of one another, which means that you can say cotangent is 1 over the tangent of theta. All right, so these are the reciprocal functions. And that's kind of the fast-paced version of it. So let's put this into practice. This reciprocal, matter of fact, there's more to it. So the reciprocal, if I know sine is the opposite over the hypotenuse, then if I say 1 over the opposite over the hypotenuse, right, like that just becomes the hypotenuse over the opposite. So we can say cosecant of some angle is the hypotenuse over the opposite, right? You just flip them, right? Secant of some angle, well, if the reciprocal is cosine, and I know cosine, caught another hippie, cosine is adjacent over hypotenuse, then the reciprocal of that is the hypotenuse over the adjacent. And then tangent and cotangent, right? The cotangent of some angle is the reciprocal of tangent. And tangent, tripping on acid, tangent is equal to, the tangent of some angle is equal to the opposite over the adjacent. The cotangent is the reciprocal of that, the adjacent over the opposite. All right, so hopefully that kind of gives you some background on that. Let us continue. So Find the values of the trig functions of the standard position angle theta, so some angle we don't know, with the terminal side passing through the point 3, 4. So I like to graph this first and just say, okay, 1, 2, 3, 1, 2, 3, 4. So we got this point, right? And it's saying, hey, there's this angle that goes through this point. I should stop it right there. So I don't know, just stop it right there. That's our angle. This is the initial side. And then we have this angle theta that we don't know. And this is the terminal side, all right, of our angle. I'm gonna erase that because that's not something that we need. It's just nice to know. All right. So what do we need? Well, first I like to create a triangle and say, okay, go right down to the x-axis, make a right triangle. And then label what you know about that triangle. Well, it's 3 right here and it's 4 right here, right? So if you want to find all 6 trig functions, first we probably need to find the hypotenuse of this triangle. Thankfully, we remember the Pythagorean theorem. We've been working with that. I know with any right triangle, I can always use the Pythagorean theorem. And it says that a squared plus b squared equals c squared. You should know how to use this by this point, so I'm just going to go ahead and plug stuff in. 3 squared plus 4 squared is equal to I'll say r, which is normally how they denote the hypotenuse, r squared. So this is 9 plus 16 is equal to r squared. That's 25 is equal to r squared. You take the square root and you get r is equal to plus or minus 5. All right. Now, since we're talking about a triangle here, we're talking about the hypotenuse. It's always going to be positive, so don't even worry about the negative. This is 5. So now we have our angle of perspective, right? Our angle right here. We have the opposite. We have the adjacent. And we have the hypotenuse. So now we can get all 6, find the value of the trigonometric functions. So it doesn't say all 6, but we're going to do all 6. So first, I'm going to do my little saying. Some old hippie caught another hippie tripping on acid. That helps me. So I'm saying the sine of this angle is the opposite over the hypotenuse. All right. The cosine of this angle is the adjacent over the hypotenuse. And the tangent of this angle is the opposite over the adjacent. That's the main 3. Then I'm doing the reciprocals. Sine, the one that goes with sine, is cosecant, right? That's the reciprocal. And that one is the hypotenuse over the opposite. Cosine, the reciprocal of that is secant. The secant of some angle is the hypotenuse over the adjacent. And then cotangent, adjacent over opposite. Now I'm ready to kind of fill that in. So let me change my color. Sure. All right, so sine is going to equal, the sine of this angle would be the opposite, 4, over the hypotenuse, 5. The cosecant is just going to be 5 over 4. The cosine, the adjacent, 3 over the hypotenuse, 5. The secant is just going to be 5 over 3. The tangent, the opposite, 4 over the adjacent, 3. The cotangent, 3 over 4. We're done. Here's my answer. The sine of that is that. Cosine of that is this, right? Got my answers. Got it all 6 of them. Boom. All right, that's finding the values of the trig functions. Same thing here, just with decimals. But all right, given the information below, find the 5 remaining trig functions. So here, it says the sine of some angle is 3/7, so 3/7. And it tells us it's in quadrant 1. All right, so we kind of got to take this into account, right? Hopefully you know by now that this is quadrant 1, quadrant 2, quadrant 3, quadrant 4, right? So all we need is quadrant 1, so I don't need all this stuff. I just need to focus on quadrant 1. All right, so quadrant 1 is all I need. All right, so I'm just going to draw a triangle right in quadrant 1. Right triangle. All right, this is the steps to go. And I know that here's my angle. It's always the angle that's connected to the origin, right? And I'm saying here, sine, I know some old hippie, right? You need this stuff. Like, it's sine of some angle is the opposite over the hypotenuse. So it tells me the opposite is 3, because 3, that's my opposite. The hypotenuse is 7. 7 hypotenuse. All right, so I got to figure out the adjacent. I use Pythagorean theorem. Same thing we just did. So I say, so this time I don't know, I just say I got the leg is what I need. So I'm going to say a squared plus b squared, right? In this case, 3 squared equals the hypotenuse, 7 squared. All right, so a squared plus 9 equals 49. Subtract 9, subtract 9. So I got a squared is equal to 40. I take the square root of 40. A is equal to square root of 40. And I should say plus or minus, but since it's always positive, hypotenuse is always positive, square root of 40. And I mean, I'm just going to break it down because I know 40 is just 4 times 10. I do know the square root of 4 is 2, so I can bring a 2 out. The square root of 10, you can just leave it like that because 10 is just 2 times 5, and you can't take the square root of 2, and you can't take the square root of 5. So this should be 2 square root of 10. All right, so now we know the adjacent. You could get the decimal. I just prefer not to, because then when you get a decimal, you're gonna have to round it, and then when you get your answer, you might be rounding it, and then when you round twice, you should only round something one time. If you round it twice, then you rounded once, and then you round it again with your answer, you're gonna be off more than you might hope. All right, so let's go here. I'm saying I know the sine, so we got sine of my angle of perspective is 3/7. So right out the gate, you should get the reciprocal, cosecant, right? That's a S. The reciprocal, it's got a C. I mean, it's going to take a little bit of work on your part, but you should be able to link that up. So 7/3. Next thing, cosine, right? Cosine. Some old hippie caught another hippie. Cosine is caught another hippie. Adjacent, cosine, caught another adjacent hippie, hypotenuse. So cosine is adjacent over hypotenuse. So the adjacent here is 2 square root of 10. The hypotenuse is 7. All right. For the reciprocal, the secant, you just flip it. 7/2 square root of 10. All right, so this right here, you're not supposed to keep answers with square roots in the denominator, but since we're just going to be getting a decimal point at some, you're not supposed to. It's not considered proper mathematics, but it is the right answer. We're just going to focus on that for now. All right, tangent, tripping on acid, right? Tangent is opposite, tripping, tangent, on, opposite, acid, adjacent, right? So opposite is 3. Adjacent is 2 square root of 10, right? And then when you do the reciprocal, cotangent, we're saying 2 square root of 10/3. You plug those in your calculator and you got the answers. All right. See anything else we got? This is the same thing, except it's in a different quadrant. I'll get you started on this, but it's just, let me check it. Let me make sure. Yeah, that would be, we'll do this one. So this says in quadrant 3, right? So first, I know, all right, let me say that. Where's the undo? Oh. All right, since it's in quadrant 3, let me just focus on quadrant 3, right? So we got quadrant 1, quadrant 2, then we got quadrant 3, and then quadrant 4, right? I'm focused on quadrant 3. So draw my triangle. Always go up to the x-axis. If you find yourself going to the y-axis, you're going to end up getting yourself confused. Don't do that. Always connect your triangle back to the x-axis. All right, so we go out. It doesn't really matter how far out you go, whatever, however far you want. I like to do it large enough to make sure that I'm going to have room. And then I'm connecting back to the x-axis, all right? Back to the x-axis. And this, the angle touching your origin is always the angle of perspective. All right, so tangent, right? Some old hippie caught another hippie tripping on acid. Tangent, opposite over adjacent, right? So when I look at this, I see there is no fraction. You can make it a fraction, all right? This is the opposite. This is the adjacent. All right, now, you also got to use a bit of common sense when you start doing this. The opposite, square root of 3. The adjacent, 1. Now, I know that this is a triangle. So we get that, we start thinking, oh, your sides can't be negative on the triangle. And that's right. Your sides can't be negative on the triangle. Especially you start talking about hypotenuse because we're talking about a distance from here to there. But when you're thinking about the x and y axis, you start thinking about the x and y axis. If I move over here from the origin, I go this way, 1. That's not just positive 1. That's negative 1, right? Because I'm moving to the left. And then I go down, right? Down. That's not just square root of 3. That's the negative square root of 3. So keep that in mind. That can be a tricky part. All right, just thinking about, if you think about any point, right? And points in either of these, like this is helpful sometimes. If I got the point A, B, in quadrant 2, that's going to be the point negative A, B, right? Because, you move to the left. In quadrant 3, that's going to be negative A, negative B. And then in quadrant 4, that would be A, negative B. So if you know this, which you should all know that, maybe you don't think about this very often, but when you do think about it, it should make pretty good sense to you. It's just applying that. All right, so I'm going to erase that, but pause it if you want to copy that down or whatever. But you think about it, you can come to that logical conclusion. All right, so we need the hypotenuse. We know 2 legs of a triangle. Want to find the hypotenuse? It's a right triangle, so we can say a squared, so negative 1 squared, plus b squared, negative square root of 3 squared, equals hypotenuse squared, or I'm going to say r squared. Everybody want to say c squared, but r kind of connects back to circles, which you'll probably get into at some point. So negative 1 squared is 1, plus negative square root of 3 squared. Well, negative squared is positive. Square root of 3 squared is 3. So that equals r squared. So 4 equals r squared. That means r is the square root of 4, which is 2. We're only going to consider the positive version, 2. All right. So now we do the same thing we were going to do before, right? Since we already have tangent is the square root of 3, right? I like to kind of think about it like a fraction. So then when I do the other thing and I flip it and say, okay, cotangent of that angle is, 1 over the square root of 3. Or we could say adjacent over hypotenuse. Adjacent is, here we got the adjacent. I said hypotenuse, but it should be opposite. And then hypotenuse, right? Cotangent is adjacent over opposite. -1 over negative square root of 3 is 1 over square root of 3, right? Sine of some angle equals the opposite over the hypotenuse. So negative square root of 3 over 2. Cosecant, you flip it. -2 over square root of 3. Cosine, adjacent, -1 over hypotenuse, 2. The secant, the reciprocal, -2. We're done. The last thing we need to talk about is just the unit circle. So the unit circle. All right, so without getting real deep into it, it's kind of a topic that I'm not sure exactly how to start without like really getting deep into it. I'm just gonna say it's a circle. Terrible. That overlays on the X and Y axis, right? And if you go, it always has a radius. The circle has a radius of 1. So this first point would be the point 1, 0. Then, this point over here would be the point 0, 1. This over here would be -1, 0. And then this is 0, -1, right? It corresponds to some angles. We have 0 degrees, then, that would be a 90-degree angle. So this is 90 degrees, 180 degrees, 270 degrees, 360 degrees, all right? Now, what's important about the unit circle is that if I create a triangle at any point on this unit circle, going to any point on the outer edge and go down, right? I have, I have an X value and a Y value, and that corresponds to a radius, right? That's why I call this R, the radius from the center of the circle to the outer edge is center. And it corresponds to a point X, Y, which we can use trig functions and say, hey, sine of this point is just the opposite over the hypotenuse, right? So opposite is Y. Hypotenuse, well, we already said radius is always equal to 1, right, on the unit circle. Yeah, I didn't extensively say that. Let me do that. Radius of unit circle equals 1, right? So over 1, sine of theta is equal to Y over 1, which is just Y, right? And that's this. So this value right here is just the sine of theta. And then cosine of theta is equal to the adjacent, which in this case would be, adjacent is X. So X over the hypotenuse, which is 1. So X is equal to cosine, right, of my angle of perspective. So, and then we know, tangent of my angle is equal to the opposite, so Y over the adjacent, X. So that's kind of a big deal. It ties into a lot of stuff. But that's about all you need to know for now. All right.